Excuse me. Okay, so this next type of problem is what's called maximum revenue. So now we're going to get into the kind of the meat of our optimization problems. The area ones just kind of get you working through the process of it. So with maximum profit, maximum revenue, it's the same process, but you don't have to draw a picture and you are getting values. Like maximum revenue, or at so many products you're going to produce maximum revenue. So here's the scenario. So an office supply company sells X permanent markers per year at P dollars per marker. The price demand equation for these markers is P equals 10 minus 0.001X. So to interpret, the X represents the number of markers. The P, and this is lowercase p, represents the price. This is the price that is going to be charged for the markers. The question is, what price should the company charge for the markers to maximize revenue? And then what is the maximum revenue? Okay, so we're going to go through the whole process. So first thing is we don't have anything to draw, so we can skip that step. Next one is we need the objective. Okay, so the objective is always what's the question, right? So we're looking for maximum revenue. That's our objective. So you have to come up with the revenue function. So if you remember way back when, from 1324, revenue is all the money that comes in. So for instance, if I sell DVDs and I charge $15 per DVD, every DVD I sell, I get $15. That's revenue. So if I sell 2 DVDs, I get $30. That's revenue. If I sell 100 DVDs, I get 15 times 100, which is 1,500. All right. So all of that money coming in is my revenue. It's not my profit. It's just my revenue. It's all the money that's coming into me. From that revenue, then I am able to pay off my employee, or pay my employees, pay my bills, pay for the rental equipment. Whatever it is that goes out is being taken from the revenue. Okay, so revenue is everything that comes in. So revenue is the price times the number of products. Well, they gave me the price. So all I have to do is do price times the number of products. And remember, X represents the number of products, right? So now I have my revenue function. So my revenue function, I'm going to distribute that X through, equals 10X minus 0.001X squared. Okay, there's my objective. Got it. All right, now I need my constraint. So the constraint in this case is going to be the price. Because if I sell it for too much, nobody's going to want to buy it. If I sell it for too little, I'm not going to make any money. Okay, so you have to have a price that is kind of a balance point. Okay, so the price is going to be really important. I can't have a negative price, right? That makes no sense. So I need to make sure that my price is greater than or equal to 0. So my constraint is the price equation. All right, so I'm going to take my price and I'm going to set it to greater than or equal to 0 because I want to make sure that my price stays positive. That's my constraint. It has to be in the positive realm. So I'm going to solve for X, divide by negative 0.001, and I get X. Don't forget to flip your inequality. So I get, excuse me, X is going to equal 10,000. I'm sorry, less than or equal to 10,000. So that is my endpoints between 0 and 10,000. Okay, so that's the constraint. I have to have endpoints. All right, So now I have my objective, I have my constraint, and I have my endpoints. All right. Now, the other thing about the constraint, remember you always want to solve it for one variable. It's already done. It's already done for you. You don't have to rearrange it and solve for x. It's already solved. That's why it doesn't matter which variable it's solved for. You just pick a variable and solve it. In this case, it's already done for you. So now all I'm going to do is plug. Oh, oh, I'm so silly. Okay, it's already set for you. Remember how we plugged our, well, let me go back up here. Our revenue is X times P. Well, I already plugged P in here. I'm good. This revenue function is already good to go. The constraint is already embedded into my revenue function. Okay, so that step is also unneeded because you already did it. All right, so here we go. Here's my original function. I'm going to find the derivative of it. There's my derivative. I'm going to set my derivative to 0 and solve for x. Divide by negative 0.002. Don't forget your negative. And 10 divided by 0.002 is 5,000. All right, now don't forget what you're doing. What we just found was the critical point. This is our critical point. So we have our endpoints and we have our critical point. Okay, so from here, I'm going to take my endpoints and my critical point and I'm going to plug it back into my original equation. And I'm going to look for my maximum revenue. Okay, so when I plug 0 into here, it goes to 0. When I plug 5,000 into here, I get, where'd it go? Oh, 25,000. And when I plug in 10,000 into here, it spits out 0. So my maximum revenue is $25,000 when I sell 5,000 markers. I think yeah, markers. Okay, so 25,000 is my maximum revenue. 5,000 is the maximum number of markers. How do you find the price? You plug your critical point back into the price function. So the price is 10 minus 0.001 times 5,000, because that's how many markers I'm going to have. And it comes out to be $5. These are very expensive markers. Okay, so each marker costs me $5. When I sell 5,000 of them, I'm going to have a maximum revenue of $25,000. And that is maximum revenue.